All right, welcome to Applications of Calculus Applications of Calculus Part 2. We are going to be talking more about integration. This is Part 3. Okay, so this is more on U substitutions. Okay. All right, so let's go ahead. We'll just do a couple of examples on this one. There's not a lot of practice with this. So integral of, we have x squared times the square root of x plus 2 dx. All right. Now, the problem with this is there is no way to get this x squared inside of the square root. We're kind of stuck with it. So if you try to say, okay, let u equals x plus 2, my du is, of course, dx, but I don't have an x plus 2 anywhere. Okay. And I don't have really good ways of putting this in here. So what we're going to have to do is we're going to have to say, well, we have u is equal to x plus 2. How about x equals u minus 2, right? All I did was subtract 2 from both sides on this. And again, my dx is equal to my du. So now when I go through to do my substitution, we've got integral of x is now u minus 2 squared times the square root of u plus 2, or x plus 2. So x plus 2 goes back to u, let's do u plus 2. Now I've got a little bit more I can deal with. I can actually multiply this u minus 2 out. This is going to be, I'm going to say that dx was du. So this is going to be, let's go ahead and multiply this out. Just FOIL this out. So this is going to be x squared minus 4u plus 4 times u to the 1/2 power. I just went through and very quickly did u minus 2 times u minus 2. Okay, you might have to go through and FOIL this out yourself. That's fine. But this is what you're going to end up with. Okay. One of the things is you can't integrate with x's and u's at the same integrand. You have to, it can only be one variable. Either pick u, pick w, pick v, pick something, but it has to be one letter. It can't be x's and u's. So now we have to go through and deal with this. When the bases are the same, we add the exponent. So this integral is going to turn into u to the 2 plus 1/2. That's going to be 5/2. Okay, we have 1/2 plus, we have 1, okay, plus 1/2. So we have minus 4, 1 plus a half, it's u to the 3/2. And we have plus 4 u to the 1/2. And we have to go ahead and integrate this. We haven't integrated yet. All we did was massage this problem so that we could integrate it. Now we're ready to integrate. So again, remember our power rule says add 1 to the exponent. So this is going to be u to the 5 halves plus 2 halves is going to be 7/2. And if you have to write a little plus 2 halves in here to make sure that you're getting this correct, be my guest and do this, okay? When the fractions get more complicated, sometimes it's better to do it this way, okay? And then we divide by 7/2, okay? Minus 4, 3/2 plus 2/2 is u to the 5/2, divide by 5/2, okay? Minus 4, 3/2 plus 1, or 2/2 plus 1 is going to be u to the 3/2, and again, we divide by 3/2. Let's see. And all we have to do is we still have to deal with this. Remember how to deal with fractions and fractions? Well, what I'm going to do is I'm going to multiply top and bottom of this fraction by 2/7. This stuff on the bottom is all going to cancel out. That's the whole point. So we end up with 2 over 7 u to the 7/2. And the same thing is going to happen. I'm going to multiply by 2/5 top and bottom. 2/5 top and bottom. This stuff on the bottom is all going to cancel out. We have 2 times 4, which is going to be 8 over 5 u to the 5/2. Okay, and then we're going to say, okay, times 2 over 3 times 2 over 3. So we're going to get 4 times 2. So we have a plus. No, that's plus. Should be a plus. This should be a plus. Okay, so we have 4 times 2, which is going to be 8. 8/3 u to the 3/2 plus c. But of course, we didn't start off with u's, we started off with x's. You have to go back and say, what the heck was x, or what the heck was u? U is equal to x plus 2. So we have 2/7 x plus 2 raised to the 7/2 power minus 8/5 x plus 2 raised to the 5/2 power plus 8 over 3 x plus 2 raised to the 3/2 power plus c, and that is the answer for how you do one of those types. Okay, I have a couple more problems for us to do just to showcase the number of ways you can do this. I have warned you that this is a problem that I know is that this is a particular technique of integration that people have some problems with. There's only a couple of examples in the book. There's a 2 or 3. But I use this on a regular basis throughout the class. So practicing this type of integral is a good thing for you to be able to do. Let's go ahead and try. We have x over, and I've got an x, the square root of x plus 3 on the bottom. Right. So let's see what we're going to have here. So normally you would say let u equal x plus 3. All right, good job. I don't have an x plus 3 anywhere to substitute on the bottom. Like my dx, my du is equal to dx, but I'm going to have a hard time changing this x into a u because I don't have a plus 3. I have 1 plus 3, I need another one. I don't have it. So what we're going to do is we're going to say u minus 3 is equal to x. Right? So let's go ahead and take a look at what happens there. So we have u minus 3 divided by q to the 1/2 power, okay, du. So let's go ahead and massage this out. So we have u minus 3 times u to the negative 1/2 power. Again, because this is a 1, we can go ahead and distribute through. Okay. If it wasn't a 1, we'd have to multiply this out. That'd be fine. Okay. But let's go ahead and deal with that. So again, when the bases are the same, we add the exponents. So we end up with an integral of, we haven't integrated yet, u to the 2/2 minus 1/2, we end up with a 1/2 power here, minus 3 u to the negative 1/2 power, du. Now we're ready to integrate. Okay, let's go ahead and do that. So we have u raised to the 3/2, the 2/3 out front, minus 3 u to the, we're going to add 1, so it helps. Go ahead and do that. Negative 1/2 plus 2/2 is going to be 1/2. And since we're divided by 1/2, we're really multiplying by 2 plus c. So we're going to say this is 2/3 u to the 3/2 power minus 6 u to the 1/2 power plus c. But still, going back to the original function, we have to integrate with respect to x. We have u's in here, so we have to go back and say, well, what the heck is u? U is x plus 3. So we're going to say this is 2/3 x plus 3 raised to the 3/2 power minus 6 x plus 3 raised to the 1/2 power. It's the square root plus c, and that's going to be our answer for this kind of a problem, right? So that's how you go through and do those. One more for us. It's probably fine as far as time goes. Let's go ahead and we have an integral of u plus 1, okay, times the square root of x minus 4. Yeah. Okay, dx. You have to go through and integrate this. So we're going to say, okay, my obvious choice, x plus 1. Sorry about that. X plus 1 times x minus square root of x minus 4. Let u equal x minus 4. Okay. And again, my problem with my du is dx. I don't have x minus 4 sitting here. I can't just go ahead and subtract 4 without adding 4, and it's still going to be a problem. So it's not going to help. So we're going to say, let's add 4 to both sides. So we have u plus 4 is equal to x. All right. So let's go ahead and substitute all of that. So we have integral of u plus 4 plus 1. That's my x plus 1. It's u plus 4 plus 1 times my square root of x minus 4. That's just going to be square root of u here. Dx is to u, so we go ahead and replace that. So we have u plus 4 plus 1. Well, that's just going to be u plus 5 times u to the 1/2 power. We still haven't integrated.
So we go ahead and we can factor this through, and the bases are the same, we add the exponents. So that's going to be the integral of u to the 2 halves plus 1 half is 3 halves. Again, we haven't integrated yet, plus 5 to the 1 half. Now we're ready to integrate, right? So we go ahead and add 1. If you need to add 1 mechanically, that's fine. So we have u raised to the 5 halves power. Gotta put the 2/5 out in front here. Plus 5. I've got u raised to the 3 halves power times 2/3 plus c. Let's go ahead and deal with that. So we have 2/5 u to the 5 halves plus 10/3 u to the 3 halves plus c. Right? Now, go back and say, okay, what was going on here? What was u? U was equal to x minus 4. Okay, so we have 2/5 u minus 4, or x minus 4 rather, was my new value, x minus 4, okay, raised to the 5 halves power plus 10/3 x minus 4 raised to the 3 halves power plus our c. Right? And that is going to be our answer for this problem. Okay, the problem stems from the fact that integral of f times g is not the integral of f times the integral of g. You cannot separate integrals like that. Pluses, sure, be my guest, do that. But with a times or it divides the integral of f of x over g, that is not going to be f of x divided by integral of g of x. Okay? If you do this, you'll be very, very unhappy that you did that. Okay? It's not going to work out well for you. You're not going to receive a lot of credit. It's not going to be good. I had a chemistry teacher who would take off more points than the problem was worth if he thought you did something stupid. And this guy, we watched him in the lecture hall. He would do logarithms without a calculator to 4 decimal places. He just knew them. Now, he thought she did something dumb. He was like, it's a 10-point problem. It's like, that's minus 12. That was so excuse me. I have never done this yet, but if you do this kind of a mistake, that you have integral of f of g and you want to do integral of f times integral of g, I'm tempted to take off more points than the problem was worth because you shouldn't have gotten out of bed this morning if this was what you were going to do. So please avoid making this mistake. Don't do this. Practice a couple of these because I've used them sporadically throughout the course when you have to remember how to do this. Okay, it's an integration technique that you have to learn how to deal with and learn how to recognize, but they're not that bad. Okay, it's just a little tricky to try to memorize them, not memorize, but try to predict when they're going to come up. And mostly what happens is you set u equal to something, and then like, I can't get rid of all the x's. What do I do? Well, instead of trying to fit with the x's, change it to the x's turning into u's, you deal with it that way. So that's when you know it's like these don't quite fit. The puzzle pieces don't quite fit together. We got to do something a little bit different. We have to force the issue, but we have to make sure that everything has a u in it or everything has an x in it. And that's pretty much how we have to do these kinds of problems, right? So good luck. Thank you for watching the video. Good luck, practice, and I will see you in the next video. This kind of concludes our review section. So thanks. We'll see you next time.